Hello, this is Mrs. Hayes, and you're watching lesson video 6.7, Solving by Inverse Operations. So, a couple things to note. I slid the page down a little bit, so at the top of your page, we could do a little bit of work here. The very first thing it mentions is having a good feeling about square roots, and I think it's been a while since you guys have seen square roots. I just want to talk about, for example, the square root of 8. Do you remember breaking this into its perfect square factor? So 4 and its other factor 2, so that you could take the square root of the 4 and call it 2 square roots of 2, or 2 rad 2, the cool way to say it. So that's the simplest radical form. There's no more perfect square factors hanging out in that 8. Another thing to keep in mind is the word inverse. When we add, the inverse of addition is subtracting. A positive 4 and a negative 4, if you added them together, would give you a 0. And when you multiply, the inverse of multiplication is division. So if you had, say, 4x equals 12, you would divide by 4 to get the x alone. So you're using division to undo multiplication. And one more thing, the opposite of squaring something is to take a square root. So in our very first example, we're going to look at how to use, can't make that 16. We're going to look at how to use square roots to get x alone. So exercise 1. Solve each of the following equations for all values of x. Write your answers in simplest radical form. That's what I was talking about up here when necessary. Again, we're solving, think get x alone, and think these are quadratic. You're probably going to have 2 values of x when you're all done, because it's x squared in the equation. These are not linear equations. So to get x alone, you're going to do the inverse of squaring, which is square root. And I always sing a stupid little song to remind me that when I take a square root, I got to put a plus or minus. So as soon as you take the square root of something, put a plus or minus in front of it. Because the number that was being squared could have been a 4, or it could have been a negative 4 to make a 16. So think about that. We're going to take the square root of x squared. The squaring and square rooting leaves you with x, and plus or minus 4, the square root of 16 is 4. So we have 2 answers. X equals positive 4 and x equals negative 4. That's what I mean by plus or minus. 2 answers. Next one, x squared equals 100. What number squared could be 100? So most of you automatically would say, oh, 10. 10 squared is 100. But negative 10 could also be squared to give me 100. So when you take the square root, put a plus or minus, and you end up with x, because squaring gets rid of the square, or square rooting gets rid of the squaring, and the square root of 100 is 10, but it could be positive or negative 10. So my 2 answers are 10 and negative 10. Some people write those as a solution set, negative 10, comma 10, in the squirrely brackets. So there's a couple different ways you could leave your answer. You could say plus or minus 10, or list them separately, or write them as a set. Okay, in this case, to get the x alone, we're definitely going to have to undo the squaring, but it's also being divided by 2, and the opposite of dividing by 2 is to multiply by 2. So we're going to first take care of the multiplying. Multiply by 2. That cancels that. 2 over 2 is 1. X squared equals 20, because 10 times 2 is 20. Now we're going to get rid of the square by taking a square root. And when you take a square root, you put a plus or minus. And when you undo the squaring, you get x alone. And now I'm going to simplify, because it mentions simplest radical form up here. I'm going to look for the perfect square factor of 20. Well, 20 has factors of 1 and 20 and 2 and 10 and 4 and 5. 4 is the perfect square factor. What did I hit down there? So I got the square root of 4. I always list the perfect square first. 5 is the other factor. So it's plus or minus 2 square roots of 5. The square root of 4 was 2. So there's my two answers. 2 square roots of 5 or negative 2 square roots of 5. Positive and negative. In exercise 2, we're going to solve each of the following. We're going to solve, which means get x alone, equations for all values of x. There's probably going to be 2 because we're looking at quadratics by using inverse operations. Our answers are going to be rational numbers this time as opposed to irrational, so we will not see any square roots of 5 like we did in the last one. We're just going to see fractions or whole numbers. So we're going to get close to the x squared by working our way in. The first thing I notice is the 10, and then the 2, and then the x squared. Just like we did with linear equations, you're going to subtract the 10 over to the other side. You're trying to get x alone. So 2x squared equals 18. Then you're going to divide away the 2, getting closer to the x squared every time. Now I have x squared equals 9. And finally, I take a square root. And when I take a square root, sing it, everyone. You put a plus or minus. All right, so I end up with x equals plus or minus 3. A nice rational number. So negative 3 or positive 3. Two answers. And you could check these by putting them back into the original. 2 times 3 squared plus 10 should give me a 28. Uh-oh, Hazel just joined me. She's going to jump on my computer. That's my dog. Okay, let's look at B before Hazel ruins my notes here. We're going to take a square root because the first thing I notice on the outside is the square. You're working your way inside to get the x alone. So you're going to put a plus or minus, and you're going to have x minus 2 once the squaring and square root cancel each other out, equals plus or minus 5, because everybody knows the square root of 25 is 5. So I took the square root. Now I'm going to add 2 to the other side. Well, if you're going to add 2, you might as well put it in front of the add and subtract to give yourself something to operate with. So you get x alone, this is a 0, 2 plus or minus 5. That's easy. 2 plus 5 is 7, and 2 minus 5 is negative 3. There's your two answers. So again, when you add the 2 over, you put it in front of the plus or minus, and it gives you something to add and subtract. So your two answers are negative 3 and 7, and you could check them by putting them in. Exercise 3, for each of the following equations, we're going to use inverse operations, and your answers again are going to be rational. So inverse operations, here we go. This time when we solve, you got to notice you have a y here, and you got to remember that solving a quadratic is all about finding the zeros, or the roots. So we have to replace our y with 0. I like to put that on the other side, so it'll look like x minus 1 squared minus 4 equals 0. I'm going to add the 4 first. I'm working my way in towards the x. So now I have x minus 1 squared equals 4. And then I'm going to take a square root and put a plus or minus. That kills the squaring. I shouldn't say kill, it's so violent. It's just, canceling it out. X minus 1 equals plus or minus the square root of 4 is 2. No more square root because you took the square root. And then the last step to get x alone, I just need to add 1 in front of the plus or minus. So I have 1 plus or minus 2. Two answers. X equals 1 plus 2, which is 3. X equals 1 minus 2, which is negative 1. Nice rational numbers. Again, we're solving a quadratic equation. I need to put a 0 in for y. So 2x plus 5 squared minus 200 equals 0. Y will be 0 at an x-intercept. Like, what was this one? We'll say this one was 3, 0. See that? The y value was 0. Okay, so back over here, we're going to work our way in towards the x. We're going to add the 200 first. He's the furthest away to both sides of the equation. 2x plus 5 squared equals 200. This guy became a 0. We used inverse operations. Opposite of adding is subtracting. Now we're going to divide this side by 2, and we're going to divide this by 2. So now I have x plus 5 squared equals 100. Now I'm going to take a square root to get rid of the squaring, working our way in towards the x. Take the square root and put a plus or minus. And now I have x plus 5 equals plus or minus the square root of 100 is a nice rational 10. Final step, I'm going to subtract 5. When I move it over to here, I put the negative 5 in front of the plus or minus 10. So I have x equals negative 5 plus or minus 10. Do the math. Negative 5 plus 10, negative 5 minus 10. My two answers are, let's see, x equals 5 and x equals negative 15. Use your calculator if you don't know your negative numbers. Okay, turn to the next page. In exercise 4, you're going to solve each by using inverse operations. We're going to get simplest radical form, or we're going to get the nearest tenth, which tells me I have to hit a calculator. Simplest radical form first. We're going to add the 2. We have 5x squared equals 40. Divide by 5. X squared is 8. Take the square root and put a plus or minus. So x equals plus or minus. I'm simplifying this. Square root of 4, square root of 2. So my answer is positive or negative 2, because that's the square root of 4, with a radical 2. Those two answers are 2 rad 2. Oh, I don't know what I was doing there. 2 rad 2 with a negative, and 2 rad 2 with a positive. This one, rounding, that tells me I'm going to have to use my calculator. So, but the process is the same. We're going to subtract 10. We'll have x minus 3 squared equals 28. We're going to take a square root and put a plus or minus. So x minus 3, cancel the squaring with the square root, equals plus or minus. I'm simplifying my 28. 4 times 7. This one's the perfect square. I'm just going to do that in one more step. Plus or minus 2 radical 7. Square root of 4 is 2. And then I'm going to add the 3 over in front of the plus or minus. 3 plus or minus 2 rad 7. Now, since it said go decimal, I really actually didn't need to simplify the square root of 28. I could have just hit my calculator. So I could have just said, let me just rethink this real quick. I could have had just 3 plus or minus the square root of 28. Since I know I'm going to be able to use my calculator, I could have left it like that. Either way, we got to take it to our calculator. So on my calculator, here we go. 3 plus 2, control x squared gives me the square root of 7. Enter. And then the quickest way to put the minus in there is to go back up to highlight it, hit enter, and then just backspace, use my left arrow, and delete the plus and make it be a minus. Not a negative, make sure it's a minus. Hit enter. So there's my two decimals, and both of them to the nearest tenth will give me 8.3 and negative 2.3. So this one gives me 8.3 and negative 2.3. The 9 made us round up the tenths place to a 3. Let me look at that decimal one more time. 8.2915. 8.2915. Here's the tenths place. The 9 makes that go up to a 3. So 8.3, and the other one was negative 2.3. Had I entered this with the plus and then with the minus, I would have had the same two decimals. Exercise 5. Francis graphs the parabola on the grid below. So there it is. He believes that the quadratic has zeros because look at negative 3.5 and positive 3.5. It looks pretty close. But we're going to find them in simplest radical form and see if he's correct or not. We're going to explain why he must be incorrect, so we know he's wrong. Okay, so we're going to change that y to a 0. We have 1/2 x squared minus 6 equals 0. use some inverse operations. So working our way into the x, start with the 6. Add the 6. 1/2 x squared equals 6. To get rid of a half, the quickest thing to do is multiply it by 2. Multiply by 2. X squared equals 12. X will be, when I take a square root and put a plus or minus, I'll have positive and negative the square root of 12. So since it said simplest radical form, you're going to have positive 2 rad 3 and negative 2 rad 3. If you didn't catch that, 12 is that, and there's the 2. So positive and negative 2 rad 3. Well, I can't tell if he's right or not, or how far off he is. So is this equal to 3.5 and negative 3.5? The best way to do this and see if his estimate was correct was to change to a decimal. So I'm going to go to my calculator and change these into, oh my goodness, what am I hitting here? Change these into decimals. So let's see, 2 radical 3. 2 square root of 3. 3.464 blah, blah, blah. 3.464. So he was not correct, but I could subtract 3.5 minus 3.464 and see just how far off or how good his estimate was. In exercise 6, you're going to find the zeros in simplest radical form and then as a decimal to the nearest hundredth. So we're finding zeros. That means x plus 4 squared minus 20 equals 0. Start using your inverse operations. Add 20 to the other side. And I have x plus 4 still squared equals 20. I take a square root and put a plus or minus. So I have x plus 4 equals plus or minus. I'm going for simplest radical form here. So I am going to call this 2 rad 5. Square root of 4 is 2. I'm going to subtract 4 in front of the plus or minus. So I have 4 negative plus or minus 2 rad 5. So this is an okay way to leave my answer in simplest radical form, but it also wants these in decimals, so take them to your calculator and calculate them. Okay, write these down, 0.47 and negative 8.47. There's your two decimals.